From building bridges, to erecting skyscrapers, to assembling airplanes and cars, welding allows engineers and manufacturers to connect metal structures. But the method of joining metal to metal through melting had remained mostly the same for decades. That is, until 1991, when a new kind of welding was invented. Instead of melting metals to connect them using high temperatures, this new method, called friction stir welding, uses friction, just like when you rub your hands together on a cold day to warm them.
Friction is everywhere, and if friction did not exist, we will not have a comfortable life. We are able to walk on any surface because we have friction that allows us to walk.
Rajiv Mishra, a professor at the University of North Texas, is one of the world's foremost experts on friction stir welding. Although Mishra didn't invent friction stir welding, he's using his imagination, a key component of the innovation process, to create new applications of this technology. In his lab at the Center for Friction Stir Processing, which receives funding from the National Science Foundation, Mishra demonstrates how friction stir welding works. He begins by taking two aluminum alloy plates clamped together tightly in a machine. A metal tool resembling a drill bit is inserted in between the plates. The tool spins as it travels along both edges. The friction created by the spinning tool heats the atoms in the solid metal, making them move around or diffuse. The metals become deformed, and atoms from both plates are bonded together without any melting.
Friction between the tool and the workpiece creates the heat, which then allows the material to become softer and become more plastic. And so the plasticized material then moves around.
In a matter of minutes, the aluminum plates have been welded together and are cool enough to touch. The bond created by friction stir welding is almost perfectly smooth and as strong as the original aluminum plates. When he first observed how friction stir welding changed the microstructure of the metals, Mishra started imagining new ways that it could be used for more than just welding.
So the idea behind that is that instead of taking many pieces of metal and then bonding it together, you can take a single piece of metal and give it a complex shape. If you look at cars, back lid of cars, if you look at aircraft doors and so on, we can change the strength of material, we can change fracture toughness.
Mishra started using the friction stir welding tool to strengthen the microstructure in more complicated metal parts that are usually cast from molds, like the rim of a car wheel.
This is a region which experiences high stress, and it is sensitive to fatigue. And so we could friction stir process the region to show that our strength and fatigue properties are much better in this region.
No one had ever attempted to use friction stir processing except as a tool to bond two pieces of metal together. Mishra's innovative way of using it to make metal stronger ultimately led to 4 patents granted by the U.S. Patent and Trademark Office.
When we took friction stir process, the process already was invented, it existed. It was just that it was being applied in one particular way, and we thought of other ways.
Through extensive testing, Mishra and his students continue to learn all they can about how the friction stir process transforms the physical and mechanical properties of all sorts of metals. Mishra hopes he can convince more designers and manufacturers that advances in friction stir processing can one day make cars, planes, and trains lighter and stronger.